All right, we're going to do two full examples here of graphs and go through every single part of this. So let's go ahead and look at the function f of x equals 3x squared divided by x squared minus 4. All right, again, let's go through every piece. So we know we need to find the domain. In order to find the domain, I'm going to go ahead and factor our denominator because it does factor. Numerator does not factor. The denominator is going to be x minus 2, x plus 2, which means the two values that I have to eliminate from my domain are going to be x equals plus and minus 2. So x cannot equal plus or minus 2. Now the good thing is, once again, that has given us our vertical asymptote. So let's go ahead and write the vertical asymptotes in there. The vertical asymptote is x equals 2, x equals negative 2, because neither one of those things are the same factor as the numerator, so those are both going to be vertical asymptotes. We need to take a look at our horizontal asymptotes. Horizontal asymptotes, we compare the degree of the numerator and the denominator. The degree of the numerator is 2. The degree of the denominator is 2. Those are both the highest powered exponents. So they are the same, which means we look at the leading coefficients and we divide them. Our leading coefficients here are 3 and a 1 here. So 3 divided by 1 is 3. So we have y equals 3 as our horizontal asymptote. And notice that the degrees were the same, which means there cannot be a slant, because in order for there to be a slant, the degree of the numerator must be exactly 1 higher than the denominator. So in this case, we're simply going to write slant asymptote, none. There aren't any. We do need to find the x and the y intercepts. The x-intercept is what you get when you set the numerator equal to 0. So the x-intercept, let's set that numerator equal to 0 and solve for that. If you divide both sides by 3, you get that x squared equals 0. If you take the square root of both sides, you simply get that x equals 0. There is no such thing as plus or minus 0, so we don't have to worry about that. It's just x equals 0. So if x equals 0, we get the point 0, 0, because y is always 0 for the x-intercept. The y-intercept is what you get when you plug 0 into both the numerator and the denominator. If I plug 0 into the top, I would get 3 times 0 squared, that's 0, over 0 squared, which is 0 minus 4. I get 0 over negative 4, that's still 0, because 0 on top divided by anything other than 0 is still 0. So then I would also get 0, 0. Okay, which means that this thing intersects the graph simply at the origin. So let's take a look at the graph. Okay, let's go ahead and put a bunch of tick marks on here. Let's see, I went out 1, 2, 3, 4. I went out 6. I can go out 6, I think, in each direction. Kind of went off my graph there, but it's okay. All right, let's go ahead and plot our asymptotes. Vertical asymptotes are at x equals 2, which is right here. Oops. X equals 2. And x equals negative 2, which is right here. Horizontal asymptote is y equals 3. So 1, 2, 3. Y equals 3 is right here. It'll be a dashed line horizontally. Those are our asymptotes. The next thing we should plot is probably any points that we have on the graph. The only point that I know is that 0, 0 is going to be our intercepts, both the x and the y intercept. So it only crosses the x and y axis one time at 0, 0. Which means, and there's kind of an interesting thing about this one, when I go to the right and to the left of my vertical asymptotes, it cannot cross the x-axis anymore. It can't touch it. So that's going to kind of help us to figure out where this thing is going to be. Let's deal with what's happening on the inside, though, in between the two vertical asymptotes. I know it hits the origin, 0, 0, that point we just plotted. Let's plug in x equals 1 and see what happens there. If I plug x equals 1 in, I am not going to write this part down, but if I plug x equals 1 into my function, f of 1 is going to give us 3 over 1 minus 4, which is negative 3. 3 over negative 3 is negative 1. So if I plug in positive 1, I get out negative 1 for a point. If nothing else, that should tell you the trend as this thing approaches its asymptote. It's going to go down towards the asymptote, and it's going to keep going down. Now, it could have actually gone up, and I know that might sound counterintuitive because it could go up through the horizontal asymptote in the middle. It just won't be able to cross the horizontal asymptote as you go out towards the sides. Let's see what happens if we plug in negative 1. Well, the interesting thing is if I plug in negative 1, I get exactly the same value. I still get out a negative 1 because once I square the negative 1, it becomes positive. So if you plug negative 1 into your function, you should find that you also get out negative 1. And so that means that this piece is going to go this direction. Again, it's going to get really close to that asymptote, but it won't actually get there. Now, we do know that outside of our vertical asymptotes, 2 and negative 2, we're still going to have something as a function. The function does exist. It only doesn't exist at 2 and negative 2 for x's. So let's see what happens if we plug in 3. Now, this one I will write down because the numbers are going to start to get a little bit bigger here. If we do f of 3, that's going to be 3 times 3 squared over 3 squared minus 4. So that's going to be on top, that's 3 times 9, which is 27. And on the bottom, we get 9 minus 4, which is 5. So 27 divided by 5 is about 5.4. I think if you plug that in your calculator, that's what you should get. So if x is 3, we're going to go right 3, and then we're going to go up 5.4 units. So 1, 2, 3, 4, 5.4 units, somewhere in that region right there. Okay, if nothing else makes sense to you, hopefully this will. As x starts to come backwards, as from the point we just plotted, from this point right there, as x starts to go backwards towards the left-hand side, as it goes towards the asymptote, it's only allowed to do one thing. It can either go up or it can go down. Well, it cannot go down, because if it keeps going down, that means it's going to cross through the x-axis somewhere. It can't, because we don't have any more x-intercepts. We already found them all. So as x goes to the left, it has to go up. And as x goes to the right from there, it's got to approach our horizontal asymptote, so it's going to start to come down and approach the horizontal just like that. Okay, let's take a look at what happens on the other side. If we do f of negative 3, plug the negative 3 in, we're going to get 3 times negative 3 squared over negative 3 squared minus 4. Well, the interesting thing is I get exactly the same thing, 27 over 5, which means that this thing is going to look identical on the other side of the graph, and that's because it actually has y-axis symmetry. It's an even function. We did not cover that one in this case, but this is an even function, so it's going to look like this. And then it's going to come down towards the horizontal asymptote like that. Now, if this doesn't make sense, if the intuition here doesn't make sense, you can always plug more and more values in and see the actual trend and look at this. And that's what I strongly suggest you do if the intuition of that particular problem didn't make sense. Plug values in so that you can see the shape, so you can see what it's doing. It'll help you sketch it. There is no limit to how many values you can plug in. So use that as a way to do it as well.